Hello, everyone, and welcome to part three of factoring, where we are just going to continue with some more examples. So, looking at number 9 here, we have y squared plus 35 minus 12y. Now, the first thing we should recognize here is that this is not in standard form. It is easier on us when we go ahead and work with things that are in standard form, like we've been working with. Remember, a lot of math is taking what you have and writing it how you know what to deal with. We know how to deal with things that look like this, so let's make it look like this, where that y term is in the middle. So I'm going to go ahead and start by rewriting this as y squared minus 12y plus 35. And what I actually want to practice in this video is not having to write down all the details. Now, this is extremely powerful, especially for what we're going to do in the next lecture video, which is looking at factoring where a is greater than 1. Okay, so very powerful, but especially when a is just 1, when right there is just a 1, it's actually we're making ourselves do a lot extra work here, especially if you are good with your multiplication and addition facts. Um, you're making yourself do more work. So what we're going to do here is we're going to say, okay, we know this factors into something times something. We know the only way to get y squared is to get y. Now, whatever goes here should multiply to give me this guy, add to give me this guy. So 35, we've got 1 and 35, 5 and 7, and that's it, right? Okay, multiply to give me a positive, add to give me a negative, means they both have to be negative, right? And then which of these adds to give me 12? 36, 12, the 5 and the 7, right? So that should be 5 and 7 is what this guy's going to factor into. Okay, so we can start, if we know our multiplication and our addition facts pretty well, we can start to skip some of the writing here. Okay, first thing I'm going to do here is rewrite it in standard form. That gives us this guy. Okay, that's going to multiply into something times something. The only way to get n squared is n and n. These two numbers should multiply to give me a negative 56 and add to give me a positive 1. So we're looking at 56, negative, add to give me a positive 1 means the smaller number has to be negative, right? Right, the only way to multiply to get a positive is a positive times a positive or a negative times a negative, right? And if they're different, it gives us a negative, right? So they either both have to be positive or they both have to be negative to get us this positive, right? Well, then we want them to add to give us a negative. The only things that add to give us a negative are two negatives. Two positives can't add to give me a negative. A negative and a positive could give you either one, right? But if we want a negative, we want to add to give them negative. That means they both have to be negative, right? So both have to be negative. Here, we want to multiply to give me negative 1. That means those signs have to be different, right? That's the only way we're going to multiply to give me a negative. And then 2, if we want them to add to give you a positive, okay, think about money. I'm going to owe some and I'm going to have some, and I want to end up having some. Well, that means I need to have more than I owe. So our smaller number or bigger number is going to be bigger, right? Or excuse me, our positive number is going to be bigger so that we end up with a positive. So our options here are negative 1 and 56, negative 2 and 28, negative 4 and 14, negative 7 and 8, and we can actually stop here. So as I go through these, I already know I'm looking for two numbers that also add to give me 1. So as I go through these, I'm adding them. I'm saying, oh, 55, that won't work. 26, that won't work. 10, that won't work. And then I get here, I'm like, oh, that's a 1. Not only do they multiply to give me what I want, they also add to give me what I want. And that's going to be a 7 or a negative 7, right? And a positive 8. Hey, this next guy. Our first question really on both of these should have been our, after we wrote them, is there any common factor? No, they don't all have a Y. None of the numbers have anything in common. Same thing here. They don't all have an N. There are no numbers in common. So there are no common factors. We always start by pulling out our common factors. So then we just moved on to doing what we do after we look for common factors. Here, there is a common factor. That common factor is an x. They both have an x, right? Okay, a couple ways to look at it. We could go back and do what we did up here on this guy and divide by those guys, or we could notice something. When I distribute this x back into this parentheses, I should get this guy, right? So there's two things there, which means there are going to be two things here for the most part. That's what's going to be here. Okay. When we know they're only one common factor. So there's going to be two things here, right? One, two. When I multiply this x back in, it should give me this guy. Well, x times what gives me x squared? Well, x times what gives me 6x? 6. So that gives me x times x plus 6. Again, we're saving ourselves from writing down some steps here, but these steps we write down are actually very powerful tools. So just keep in mind that this is what's happening behind the scenes here, right? That and that. Okay, next guy. First things first, do they have any common factors? The answer is no. Now, this is weird because it has two variables. Okay, but it kind of looks like the rest of them, right? We have this m squared, which could act like x squared. We have something times this m, something times the x, and then we have this thing without an m, right? It looks like this guy, right? X squared, something times your x, no x's. M squared, something times your m, no m's. So it's going to factor just like those other guys did into something times something. The only way to get m squared is m and m, right? The only way to get n squared is n and n, right? And then we're getting a negative, right? This times this will always give us this last term, right? How do I know that? That guy, right? Always gives us our last term. We want it to be negative, but then we want them to add to give us something positive. That means one's going to be positive, one's going to be negative. Okay, and then there's some number here, right? Oh, well, then the A times the B has to give me that negative 42, and the A plus the B has to give us that 1. Right? Only way to get m and m. Only way to get n squared, n and n. And then this is something with m and n. So it's going to be come from this guy and those guys. Okay, so what are our options here? Well, multiply to give me a negative, add to give me a positive means smaller number has to be positive. So negative 1 and 42 is an option. Negative 2 and 21. Negative 3 and 14. Negative 6 and 7. And that is the money right there. All right, this guy's 41, not what I want. 19, not what I want. 11, not what I want. 1, that's what I wanted. So it's going to be a 6 and a 7. And the 6 has to be negative, right? So, excuse me, we don't want to do that here. We just say it's plus something times n. And then what is that something? That something is a 7n, right? What is this something? A negative 6n. So then this factors into m minus 6n times n plus 7n. You could have also not done the n's and instead done something like this. This is going to factor into n plus something, n plus something. Those two things have to multiply to give me my negative 42n squared, and they have to add to give me an n, right? Because remember, they add to give you the thing connected to the m or connected to the x, right? All right. Either way, you get m minus 6 and m plus 7. Next guy, no common factors here, so we immediately start. This is going to be something times something. The only way to get x squared is x and x. Then we will have, I'm going to write out the details here, and then the last one I won't write out the details. Plus a number, plus a number. We want those two numbers multiplied to give us 90. And we want those two numbers added to give us a negative 91. Multiply to give us a positive, add to give us a negative means they both have to be negative. So our options are -1 and -90, and I'm going to stop right there because add those together, we immediately get what we want. So this will factor into x minus 1 times x minus 90. Last guy, first things first, is there anything all three of those have in common? The answer is yes, a 2 and an A, and we're even going to pull out a negative. Why? Because that highest power term is negative, and we know life is easier when it's a positive. So I'm going to pull out a negative 2A. Remember what we're really doing? We're dividing everything inside there by 2A then. And not just 2A, negative 2A, right? So I'm going to write this as negative 2A cubed over negative 2A plus a negative 8A squared over negative 2A plus 24 over negative 2A. A's cancel out with A's. Negative 2's cancel out with negative 2's. Negative 8 divided by negative 2 is a positive 4. 24 divided by negative 2 is a negative 12, leaving us with negative 2A times A squared plus 4A minus 12. And then look at this guy. This guy looks like this guy, right? We can factor it. That's going to factor into that negative 2A is still going to be out there, right? But then it's going to have A plus some number. We can't use A, so let's use B and C this time. Times A plus some number. We know those two numbers being multiplied should give us that negative 12. And we know those two guys being added should give us a 4. Well, what are our options for 12? Add to give a positive, multiply to give me a negative means my smaller number is negative. So -1 and 12 would work. -2 and 6. And I'm going to stop there. Top one gives me 11. That doesn't work. Bottom one gives me 4. That's what I wanted. So this will factor into negative 2A times A minus 2 times A plus 6. And that is all for our factoring where A equals 1. Go ahead and move on to the next set of lecture videos.